Today I'm going to go through how to find the common factors of a set of numbers and also how to find the GCF of two or more numbers. GCF in math is a standard mathematical abbreviation that stands for the greatest common factor. So we use the greatest common factor when we work with fractions. And so this is another what I call important fraction puzzle piece that you're going to need in order to work with fractions successfully. So first, let's go through on how to find the common factors of, and we'll start off with just a pair of numbers. So let's say you want to find all of the factors that both the number 16 and the number 18 have in common with each other. One quick way to do this is to make a rainbow pattern or a factor rainbow for both numbers. So we'll take 16 first. 1 times 16 is 16. 2 times 8 is 16. 3 times nothing is 16. 16 is not divisible by 3. 4 times 4 is 16, and I can stop there because I have repeated factors. 4 is in the same rainbow arc as the other 4, so we have repeated factors. And remember, when you repeat factors, that's how you know you have found all of them. So the factors for 16 are 1, 2, 4, 8, and 16. Now, let's find all of the factors for the number 18. 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. 4 does not go into 18 evenly. 5 won't go into it evenly. And then 6 is where we repeat factors. So that's how I know I'm finished. All of the factors of 18 are 1, 2, 3, 6, 9, and 18. Now that I have all of the factors listed, one right on top of the other, this makes it much easier to compare them to see which factors both of them share or have in common with each other. So I'm just going to go through and circle them. 1 is a common factor of both 16 and 18. 2 is another common factor. And then when I look down, 4 is not a common factor of 18, 8's not a common factor, and so on. So there are no other factors that 16 and 18 have in common with each other except for 1 and 2. So for the common factors, the only common factors that 16 and 18 share are 1 and 2. So this is one way that you can find all of the common factors. Now, we want to identify the greatest common factor, or also known as the GCF. Well, just like it sounds like in the word, greatest, of course, would mean the largest factor that both of them have in common. So obviously the largest common factor is the biggest number. So the GCF for 16 and 18 would be 2. Okay, now let's try the same thing with a different set of numbers. But this time, let's find the common factors and the greatest common factor of 3 different numbers. So let's do 10, 15, and 30. Well, now I have 3 numbers, so obviously I'm going to need to do 3 rainbow patterns or factor rainbows to find all of the factors. So I'm going to start with 10. 1 times 10 is 10. 2 times 5 is 10. 3 times nothing is 10. 4 times nothing is 10. 5 times 2 is 10. So I've repeated factors. I have found all of them. 1, 2, 5, and 10 are all of the factors of 10. Now let's do the factors for 15. 1 times 15 is 15. 2 will not go into 15 evenly. 3 times 5 is 15. 4 won't go into 15, and 5 repeats. So all of the factors for 15 are 1, 3, 5, and 15. And last of all, the factors for 30. 1 times 30 is 30. 2 times 15 is 30. 3 times 10 is 30. 30 is not divisible by 4, so we'll leave that out. 5 times 6 is 30. And then 6 times 5 is 30. That's where we repeat. So we have found all of the factors. 1, 2, 3, 5, 6, 10, 15, and 30. Now, for the common factors. So the factors that are found in all three numbers, all three of them share a factor of 1. So 1 is a common factor. Now, when you look at the number 2, or the factor of 2, you notice that 10 has a factor of 2 and 30 has a factor of 2. But since 15 does not share that common factor, 2 is not a common factor for all three of them. So I've got to find the next factor that all three of them have in common with each other. Well, here's a 3, but there's no 3 up here, so that's not a common factor. Okay, here's 5, and here's 5. So 5 is the next common factor. And as I look down the row on each one, here's 10. There's not a 10 here. There is a 10 here. So the only common factors that 10, 15, and 30 share with each other are 1 and 5. Therefore, the greatest common factor, or the largest common factor, would be 5. So even when you have three numbers you're trying to find common factors for, you just simply have to make a separate rainbow pattern for each one of your numbers and then circle the ones that all three have in common with each other. Now, let's go back to another set of 2 numbers. Let's try to find the common factors for 17 and 21. Okay, so rainbow pattern for 17. 1 times 17 is 17. Now, I could keep going and keep on finding factors until I repeat factors. However, I already know that 17 is a prime number. Prime numbers have exactly 2 factors, 1 and itself. So I know that on this rainbow pattern, I'm finished. Now, if you did not recognize that 17 was a prime number, of course, you would have to keep going through your factors until you repeated, but you wouldn't repeat until you got to 17 again. Okay, now let's take 21. 1 times 21 is 21. 2 times nothing is 21. It's not an even number. 3 times 7 is 21. 4 won't go into 21 evenly, 5 won't go, 6 won't go, and 7 repeats. So I have found all of the factors. 1, 3, 7, and 21. Now let's circle all of the common factors. Well, they both have a 1 in common, and actually that is the only factor that they both have in common. So 1 is the only common factor. Therefore, in this case, the greatest common factor, or the biggest common factor, is a 1. That will happen sometimes. Now, I want to focus just on the greatest common factor. There is one other way that you can get or find the greatest common factor, and that is to do ladders, or sometimes I've heard it referred to as an upside down birthday cake. Basically, here is how you would do this. Let's say we want to find just the greatest common factor for the numbers 16 and 24. Now, This time we're going to put the numbers side by side each other. We're going to leave a little space in the middle. Okay, I'm going to make kind of a bracket, or if I was looking at this kind of looks like a rung on a ladder. Now, off to the left, right here, I want to think of the smallest prime factor that both 16 and 24 have in common with each other. You always want to think of the smallest prime number. Now, many times students at first think, oh, well, 1 is the smallest number because 1 goes into 16 and 1 goes into 24. But remember, 1 is not a prime number. 1 is neither prime nor composite, so we can't use 1. If you recognize that both numbers are even numbers, makes it a little bit simpler. 2 is the smallest prime number that both of them have in common with each other. So now we're just going to do a little division. 2 goes into 16 8 times. We put the 8 directly below the 16. And now 2 goes into 24 12 times. Now that finishes that rung or part of the ladder. So now you look at the next step, 8 and 12. And you ask yourself, okay, is there a common factor, prime factor, that both 8 and 12 share in common? Well, once again, both 8 and 12 are even numbers. All even numbers can be divided by 2, so we're going to use 2 again. 2 goes into 8 4 times. 2 goes into 12 6 times. Now, look at the next level, 4 and 6. What is a common prime factor of both 4 and 6? Well, they're both even again, so we can use 2. 2 goes into 4 2 times. 2 goes into 6 3 times. Now, on our next level, just keep asking yourself the same thing over and over. Is there a common factor of both 2 and 3 that's a prime number? Well, up to this point, we've been able to use 2 each time. But now, we can't use 2 because 2 will go into 2, but 2 does not go into 3 evenly, so we can't use 2. The only common factor now for 2 and 3 is a 1. When you get to the part or the level to where 1 is the only common factor, you are finished. So this is what our completed ladder looks like. And if you kind of look at this, it sort of looks like the steps or the rungs on a ladder. Now, to find the greatest common factor, all you have to do is look at all of the numbers on the left side of the ladder and multiply them together. 2 times 2 is 4. 4 times 2 is 8. So the greatest common factor for 16 and 24 is 8. If we did this in the rainbow patterns, we would find the exact same thing, but we would have to do slightly more work. And I'm just going to run through that really quickly to show you how much work and time you actually save yourself. So I'm going to move my ladder work over here. And now I'm going to show you how you could also do it with finding common factors, then the greatest common factor. Okay, so 16. Now I'm going to run through this pretty quickly. 1 times 16 is 16. 2 times 8 is 16. 3 won't go. 4 times 4 is 16. I repeated, so I'm finished. 1, 2, 4, 8, and 16 are the factors. Now for 24. 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. 5 won't go into 24. 6 repeats, so I'm finished. 1, 2, 3, 4, 6, 8, 12, and 24 are all of the common factors of 24. Now we circle the common factors. 1, 2, 4 is a common factor. 8 is a common factor. It's okay if you have to kind of circle diagonally. And that's it. So now when you look of all the common factors, which are 1, 2, 4, and 8, the greatest common factor is 8 which that's what we found over here in the ladders. So hopefully you can see that when you compare all of this work to find the greatest common factor to what we did over here, you do much less work in the ladders in order to find the greatest common factor. Now, let's try another example, and I'll show you why sometimes it's called the upside down birthday cake. It's actually just a slightly different way to kind of draw in the basic pattern of what you're working out. So you'll kind of get the idea once you see this. Okay, let's take the numbers. This time, let's do 25 and 30. So we want to find, once again, the greatest common factor for 25 and 30. All right, so the smallest prime number that will divide into both 25 and 30. Well, I can't use 2 because 25 is an odd number, and odd numbers aren't divisible by 2. However, I do notice that both numbers end with a 5 and a 0, so according to my divisibility rules, I know they're both divisible by 5, so I'm going to start with 5. 5 goes into 25 5 times. 5 goes into 30 6 times. Well, I just noticed this probably wasn't the best example to show you why it's also called an upside down birthday cake. But I'll go ahead and finish this one and then show you another one. The reason why this isn't a really good example is because I'm finished. The only factor that both 5 and 6 have in common is a 1, so that means I'm finished. So remember, the greatest common factor is always found at the numbers to the left. Now this time, since there was only one number to the left, I don't have anything to multiply. So 5 is the greatest common factor for 25 and 30. Okay, let me try to get a little bit better example to show you why it's sometimes referred to as the upside down birthday cake. Let's try 50 and 100. Okay, I think this will definitely kind of be a better example. Now, both numbers, 50 and 100, are even numbers, so I know they're divisible by 2. 2 goes into 50 25 times. Now notice I scooted this over just slightly. 2 goes into 100 50 times. Now, I'm going to look at the next level. What is a factor that both 25 and 50 have in common? Well, they both end in a 5 and a 0, so I know they're both divisible by 5. 5 goes into 25 5 times. 5 goes into 50 10 times. Now on this level, they both, obviously we have a 5 and a 0, so I know once again they're divisible by 5. 5 goes into 5 1 time. 5 goes into 10 2 times. Now on the last level, the only common factor 1 and 2 share is a 1, and remember, if that's the only common factor, then you are finished. Now, to find the greatest common factor, once again you still look at just the numbers on the left and you multiply them together. 2 times 5 is 10, and 10 times 5 is 50. So the greatest common factor for 50 and 100 is 50. Now, if you look really carefully, you can hopefully see why it is sometimes referred to as the upside down birthday cake. Because when I scooted in, let me kind of back this out a little bit so you can see what I've done. There, take that off. You can kind of see that if you were to turn this right side up, this kind of looks like the way tiers of a birthday cake are kind of stacked one on top of the other. It really doesn't matter which way you do it. I personally just prefer to call it ladders and just keep them all lined up, nice and straight, one right under the other. I just think it's a tiny bit less confusing when you do that. So it's really just whichever way you prefer. So when you are finding just common factors, doing the rainbow pattern is going to be very helpful to you. And if you find the greatest common factor, you can use the rainbow patterns. However, just all by itself, finding greatest common factor, you may find the ladders or upside down birthday cake a really good process and quick, easy process for you to use in order to find greatest common factor.